Hi, in this demo, this is the final demo, we're going to look at collision. And I've just modified SpriteKit Demo 5. So when you open the SpriteKit Demo 6 zip file, you'll have SpriteKit Demo 5 again. So you want to make sure to delete the old SpriteKit Demo 5 before you run this demo. When we look at collision, we need to assign a category to each physics body that we want to examine in the collision. And we usually just assign a UNT32T category to each category of physics body that we have in our scene. So the example that Apple gives you in the SpriteKit programming guide is a spaceship scene, which has spaceships and planets and missiles and things like that. And they set up a collision graph, and they show you how to do this. All we do really, though, is we assign a unique category. So this is a 32-bit integer, unsigned integer. And we're just using 1 and then shifting it to the left. So if we had another category, we would shift it, shifting it to the left by 2, and so forth. So we've got a category on the smiley, and we've got a category that we're going to set on the walls. Remember that self actually has a physics body that is the edge loop. So we need a category for that. Otherwise, when we detect the contact between these guys, the contact will be detected between the wall and the smiley, and we don't want that. We want a collision to occur there, but not a contact. So what's the difference? A collision is when two bodies should bounce off each other or collide or not be able to occupy the same space at one time. A contact is when we want to detect that for the purpose of running some other code. So here we're going to detect contacts between smileys so that we can delete the slower smiley or remove the smiley that has the lowest velocity, the aggregate velocity. So let's see how we use these categories. When I set up my nodes, you'll notice that I'm going to add the categories to a smiley before I add the smiley to the scene. So first of all, I need to set the physics bodies, the category bit mask for the smiley and the wall. The wall could have been done outside the loop, but just for simplicity, we do it here for each time. The category bit mask on smiley is the smiley category, and the category bit mask on the wall is the self physics body is the wall category. And now here we go with what will smiley collide with. This can be an ORed up list, and that's what we've done here. Smiley will collide with walls and other smileys. But what will the contact delegate be called for? And this is a list joined by OR again, but the contact delegate in this case is only going to be called for the smiley category. Now, we have to do a couple of other things. We have to make sure that this scene itself, the physics world's contact delegate, is set to the scene itself, or what any other class we want to make the delegate of this. And we also have to include or make the scene itself adopt skphysics contact delegate here in the header file. Okay, so with that set up, we can create our didBeginContact method. Now, if we look at the various methods of the contact delegate, we can see that there are others. They are all optional. didBeginContact, didEndContact, and so forth. So this is our protocol, skphysics contact delegate. So we can see the beginning and the ending of a contact. We're using didBeginContact. So the first thing we want to do is find which one of the bodies that is in the contact is slower. The contact object here is an skphysics contact. and it has two properties, body A and body B. And these are the two bodies arbitrarily assigned in the contact. So we're getting the velocity of A by taking velocity.dx and adding it to velocity.dy. We're just getting an aggregate velocity. This is an unscientific method. We're just adding up the two components of the vector, of the velocity vector. And then VB we get similarly by taking body B's velocity, delta x, and velocity, delta y. So then we assume body A is slower. We'll correct that here in a minute. But we're just assigning slower body with contact.body A. And then we disprove it if the VB, the body B is slower. We just disprove that. And then we need to look through the self.children array. Self.children array is the node tree of all sprite nodes. So what we need to find is the actual sprite node in the node tree that has the same velocity as the slower body. So we take dx and see if it's equal to slower body dot velocity dx, and it with dx on the physics body, and see if it's equal to dy, and see if it's equal to slower body dot velocity dot dy. If it is, this is the node we want to remove. So then we just call remove from parent on the node, and there we are. So in this particular simulation, I am creating 4 physics bodies, and if I run it, each time there's a collision, the slower body will be called from the scene. There we go. And we're left with 1. We should always be left with 1. And so no other collisions can occur. Well, collisions are occurring between the physics body and the walls, but the contact delegate cannot be called anymore because there are no more smileys for this to collide with. So that's it. Now, you can do anything you want within this contact delegate. We could have game code in which we initiate some sort of combat comparison to find out which will win. We could bring up an entirely new scene that said, okay, we had a contact, therefore we need to go to a combat scene. We could do any number of things here. And this is a very powerful technique for examining collisions and contacts. All right, so I wanted to do one other thing. I wanted to show you the emitter, the SK emitter node editor. So let's go ahead and do that. To look at an emitter, we need to create a new file, and that file is going to be under resources, and it's going to be a SpriteKit particle file. So we're going to go ahead and create that. Now we have some different options here for particle templates, various options, and we'll just use Fire for this test, and then we'll just add it to our folder. And we see immediately that we can see the particle SKS file. Now, if we bring up the editor, we can see that we have all sorts of properties that we can play with here. We can change the number of particles. Let's say we only want 50, and that will alter our fire immediately. We can change the range. We can change the rotation angle. This is roughly 90, but if we say 45, for instance, then the fire will burn at 45 degrees, and so forth. So this is how we create emitter effects to be added as emitter nodes to other nodes. And that's it. So you can certainly look at the SpriteKit programming guide, which contains a wealth of information on all of these topics and more. SpriteKit is a very big subject. We have to draw the line somewhere because, quite frankly, I could continue to talk about this for weeks. So this is this has been a very high-level overview of the concepts involved in SpriteKit programming. Thank you very much.